Hey, what's up guys? Welcome to another WebAssign problem. This time it's about rotational dynamics, and the problem says that a centrifuge rotates at an angular speed of 3,650 RPM. When it is turned off, it rotates 50 times until it stops spinning. Now the question here says, find the constant angular acceleration of the centrifuge in rad per squared second. Now, I've written some steps we're going to follow here, 1, 2, and 3, as you can see. So, first of all, we're going to convert the initial angular speed from RPM, which is this, to rad per second. Now, there is a conversion factor that says, hey, if I got 1 RPM is equal to 2 pi divided by 60. Now this is rad, of course, and now this is seconds. So my initial angular speed, which is omega, it will be 3,650 RPM, right? But we need it in rads per second. So in order to do that, we just need to multiply the RPMs that we've got times 2 pi over 60. Now this will give us a value if we plug it into the calculator. Let's find out. Got 3,650 times 2 pi, and we divide this by 60. It gives me 382.23. rounded. And also remember rads per second. Just gonna write it right here. Rad per second. Okay, now step 1 completed. We've got our initial angular speed in rads per second. Now we need to calculate the angular displacement, which will be needed in order to calculate the angular motion, to work with the angular motion. And why? Because there's this formula that says, hey, you've got the final angular speed will be equal to the initial angular speed plus 2 times the acceleration times the angular displacement. And so in order to work with the angular displacement in here, we need to calculate the angular displacement, right? Obviously. So then we've got that the angular displacement here would be the reps, which are 50 times, and times, we're going to put 50 reps, times 2 pi rad divided by rad. So now the angular displacement, here we can see the revs get cancelled, and so we get 50 times 2 pi, which is 100 pi. Now we could work with this angular motion formula because we need to get A, right? As it said, angular acceleration, A. So we could put this as 0, the final angular velocity, angular speed, because when it stops spinning, it's our final speed, while the speed will be 0, right? So now we just need to clear this guy, this A, because we've got our initial speed and we've got our angular displacement right here. I'm gonna put like just this to know. So we've got that now A would be, I'm gonna move this guy to the left. Now it is negative. And then we're gonna get these 2 and this angular displacement gonna be dividing. So now we're just gonna plug in our values in the formula and we'll get that negative 382.23. 382.23 squared 2 times 100 pi. Now, I'm not going to use the units right now because if we're talking about acceleration, we're going to get just an answer of distance divided by cubic unit of time, which is seconds. Now, in this case, will be rad per squared second, as it says in here. So just a little bit more simple. And so we've got now that if I plug in my values into the calculator, I'll get that minus 382 times 23 squared, divide this by 2 times 100 pi. I'll get an answer of negative 232.52 rad per squared second. And now, why is it negative? Because the acceleration is going on the opposite direction of the initial speed. Because now this is slowing down the system, right? So it must be negative. That's why it's the sign. And so then this is another WebAssign problem, rotational dynamics problem with Bob, el profesor.